Subnautica's Grand Ocean is one of the most captivating and detailed of all time. It's teeming with life at every corner of its roughly 20 unique biomes. Each and every one of these biomes are, in my opinion, masterfully crafted out of a place of passion for the world of 4546b. From the deep depths of the active lava zone all the way to the kelp forests near the surface, each biome is an ecosystem in and of itself. Even the first biome that Riley interacts with is exemplary of the very thought put into this world. And with that, I welcome you to the Safe Shallows. Upon entering the Safe Shallows for the first time, the first thing you'll notice are the shoals of fish swimming all across the environment, darting in all kinds of directions, some migrating, some mating, most searching for food. Amongst the masses, we spot a bright orange. It's a peeper. The wildlife populations of the Safe Shallows is telling of an environment mostly devoid of predators. With the various populations in the Safe Shallows, there is visibly a very hard skew towards non-predatory individuals. Take our peeper, for example. She swims across the area, searching for a suitable piece of coral to take a chunk out of with her specialized beak. This behavior mimics that of our home Earth's parrotfish. I'd expect most of the fauna here to feed on the local coral organisms the most, as, aside from vegetation, they are by far the most numerous kind of organism in the Safe Shallows as a whole. The coral here in general evolved to filter as many nutrients through their surface area as possible. We see this in their design, some content with attaching to the terrain and others growing into plates and tubes, allowing for more water and thus more nutrients to pass through their surface area. By far the most successful model of coral, though, is of course the giant coral tube. This colony of organisms has, over the years, been shaped into a tube with the greatest amount of surface area for water to pass through, both inside and outside. Specimens of this species can be found all across the map, but by far the most outstanding one is the exceptionally large giant coral tube, the huge coral tube, if you will, which has grown and expanded so large that it houses an ecosystem in and of itself. It's become entrenched into the surrounding terrain, becoming one with the geology of the place, and serving as a home to fish and even more coral. Above the producer level, we have the primary consumers who make up the bulk of the Safe Shallows population. These are your boomerangs, bladderfish, and of course, peepers, who all consume the corals and vegetation seen in the Safe Shallows. One of the most interesting specimens above this level of the food chain is one you may know well from your first time exploring the sprawling cave systems below. The crashfish is a particularly unique organism which has evolved a symbiotic relationship with the organisms known as sulfur plants, using them as its nest. Over the years, individuals of this plant species beat out others by evolving to feed off of the sulfur deposits that the crashfish naturally secreted. Over time, specimens who were tougher, fit the crashfish better, or were simply more receptive to the presence of the crashfish got all the nutrients, while the rest died out, leading to the sulfur plant that we know today. The Safe Shallows are home to lots of small herbivorous fauna, but that doesn't mean it doesn't possess the conditions for larger life. Navigating our way through the schools of fish, we find a pair of two gentle giants swimming around each other peacefully. These are gasopods, and if you've ever played Subnautica, you're probably asking me why I called them giants just now. I mean, they don't seem that big in game. Well, yeah, these guys are about the size of a small school bus, a lot bigger than the game makes them seem, which is a common trend in Subnautica due to its camera mechanics. The size of these manatee-like organisms would likely require them to consume hundreds of pounds of plant matter per day. This body plan was of course permitted due to the severe lack of predators in the Safe Shallows. However, predators from neighboring biomes still pose a threat, so the question still remains. How did these guys not go extinct from just being so big and slow, kinda dumb, and just an overall good meal for any predator worth their weight? Well, for that we have to look at the kind of symbiotic relationship that they've entered. The gasopod has a specialized organ centered around its mace-like tail. In this gland, we see the growth of algae that are presumably a separate life form from the gasopod itself. Similar to the symbiotic relationship the crashfish has developed with the sulfur plant, the gasopod has allied itself with a species of algae capable of emitting a poisonous compound, which hurts like hell. As we can tell throughout the world, we don't really see any large groupings of algae like this, and the atmosphere isn't exactly toxic, which tells us that this species of algae has adapted entirely to grow within the gasopod's dedicated algae gland, the presence of which alone tells us that these two organisms evolved hand in hand. And if you thought defense was the algae's only use, don't be so quick to assume, as the gasopods are also said to use the algae in plenty of social rituals. Chemical differences in each gasopod's algae sac may define parameters such as temperament, mating suitability, and even faction. The safe shallows are brimming with so many interesting forms of life, and as with all life in an ecosystem, they provide energy to each other. To represent this, I created a food web to represent just how much energy flows around the system. As we can see here, the plants and coral provide a majority of energy to all the organisms, with the exception of the crashfish, who is documented as a carnivore, even though we don't really see them eating any other fish. And interestingly, the bladderfish, who gets nutrients by filtering out the surrounding waters through its bladders. Additionally, there's the floater, a symbiotic colony of microorganisms which will feed on the nutrients of whatever it attaches to for, presumably, the grand majority of its life. And of course, at the very bottom, alongside the floater, there's the shuttlebug, a scavenger that feeds on waste and other nutrient deposits that come from all the rest of the organisms in the ecosystem. Now, you may have noticed that in the base of the food web, there are two primary producers, the sun, as it is in any ecosystem, and an image of a hydrothermal vent/geyser located in the safe shallows. And that's because the safe shallows, and the map as a whole, are very unique in their nature. Something that's important to understand for this analysis is the fact that the whole setting is contained in what is known as a guyot, or a table mount. A table mount is essentially an underwater volcano that formed any amount of time ago that breached the surface at one point, but while dormant, was eventually eroded back down under the water. This is a cycle that could probably repeat for millennia, with the volcano alternating between receding when dormant and once again breaching the surface when active. The most important takeaway from this is that the entire system is built on top of a volcano, which serves a variety of purposes for the ecosystem. For one, it promotes a variable amount of biological diversity by depositing a plethora of important minerals into the greater table mount as a whole, which allows for the existence of chemosynthetic microorganisms. These geysers here, seemingly caused by the table mount's volcanic activity, likely served as a kind of nutrient pump for millions or even billions of years in the past, giving all the local microorganisms the nutrients they needed to survive, and maybe even evolve into all the creatures that we know today. The use of those geological products is what's known as chemosynthesis, and we can assume that there are still many chemosynthetic microorganisms that are simply unseen to the player. This is a stretch, but I believe these organisms in turn provide a separate base for the food chain made entirely of the microorganisms that never evolved out of it. These microscopic bacteria, as all things do, produce waste and die in droves, and saturate the environment in doing so. According to the PDA's database, collecting these nutrient deposits floating in the water are the purpose of all these corals' unique shape. Ordinarily, I would assume that all the coral are photosynthetic in nature, which the PDA does to an extent say. However, I believe it would be best to assume that the most of what they need comes in the form of those nutrients that flow through the water, as those are the shapes that beat out all the others on the evolutionary timeline. They have to at least partially be photosynthetic though, as not only would it just make sense, but there is also an excerpt in the PDA entry of the table coral which says that the several coral formations we see compete for the most exposure to sunlight, with the ones towards the top being more successful. We may not realize it at first, but in a mostly deep-sea planet like this one, the safe shallows, and by extension the surrounding areas, are actually a remarkable occurrence in terms of survivability. On a planet like 4546b, constant exposure to sunlight is a hot commodity and not seen anywhere but near the ice caps, as seen in Below Zero. Interestingly, the safe shallows are actually the oldest part of the table mount that makes up Subnautica's ecosystem. In a guyot, it's the bottommost part that's the newest, which means places like the kelp forests, grassy plateaus, and of course the safe shallows were permitted the longest amount of time to develop into the ecosystems we know today. It is this crucial time permitted by this one chance geological occurrence that gives life in Subnautica as we know it a chance to survive. If not for this particular guyot, truly there would be nothing across the vast majority of the planet save for microscopic algae drifting through the vast and empty seas. A lot of people tend to say that if the Aurora crashed anywhere else on the planet, the crew would have been ravaged by the ghost leviathans we see inhabiting the void, but even they only exist due to the crater, spending most of their juvenile lives within the guyot. Again, barring the Arctic poles, evidence of life on planet 4546b is simply minimal, almost non-existent, and getting into some spoiler territory, it's a miracle that such a remarkable species could have ever been discovered in these depths. Now, this miracle is just that, a miracle. While the formation of the crucial time needed for the evolution of life was in fact provided by this geological phenomenon, the length of its current stability is but a blip in the planet's geological timeline. This means that everything here, including the safe shallows, is at risk of a mass extinction event, although that apocalypse isn't to come for millennia. A catastrophe that may come sooner, however, is something that may come as a result of the safe shallows' mostly predatorless nature. While yes, there are the stalkers who wander in from surrounding biomes, and there are the crashfish who are stated to be carnivores, the lack of predators native to the safe shallows is certainly troubling for the longevity of the ecosystem and its continued biodiversity. These things are a delicate balancing act, where every trophic level plays a seriously important role, and the lack of predators to keep the populations of the rest of the fish in check tell me that in a couple hundred to 1,000 years' time, the safe shallows may see a major ecosystemic shift, or even collapse. The population of all these fish, peepers, boomerangs, garyfish, etc. will continue to rise until the coral and plant population will no longer be able to keep up. Towards the end of those days, I see one of two things happening. The more likely option will be that all plant and coral life does in fact die out, and subsequently, all of the species will either move into different biomes, which they've already started to do since almost all the fish in the safe shallows can be found in other biomes, or just die out, ultimately leaving the safe shallows nothing but a barren waste, maybe even being replaced by the kelp forest itself, but that's not a very entertaining option now, is it? A second possible option I see happening is a shift in the amount of carnivory we see in the local species. For one, we could see a more mass migration of the stalker species into the safe shallows. After all, with the overpopulation of prey animals, it would be very easy to nest in that area and be set for a good long time for food. Additionally, if this goes on for long enough, we could even see a carnivorous shift in the already established prey animals. The boomerang, for example, has already developed sharp teeth to shred through hard corals. I wouldn't be surprised if enough time passed that it began to get some carnivorous eating habits, maybe starting off as just consuming the carcasses of dead fish and other animals, working all the way up to predation on the nearby species. If adaptations like this could occur before all plant life in coral went extinct, we could see a chance for the safe shallows to persist, although in a very new, more unsafe way. We could also maybe see the crashfish abandon its self-destructive tendencies, as with a lack of food it would have less incentive to have this behavior, allowing them to make a more significant dent in the prey population, but possibly causing a decline in the sulfur plant population. The creature most in danger, though, is definitely the gasopod. Something of its size would need to consume at the very least hundreds of pounds of plant matter per day. The only future I really see for it is downsizing or, sadly, extinction. The safe shallows is a remarkable environment. being presumably the first ever biome of 4546b encountered by another human being, aside from maybe the crew on the... It is truly a beautiful place to behold. Around every corner, life persists through the currents, on the terrain, and in the caves. The sheer amount of biodiversity seen in this place is a spectacle. A temporary oasis in a vast sea of dark nothingness whose impermanence makes it all the more fleeting. In a way, it reflects a first playthrough of Subnautica, a fleeting moment of temporary reprieve, a sanctuary keeping you safe from the rest of the difficulties in the crater, one that, while temporary, leaves a lasting mark on the player. In the same way, the Safe Shallows is a reprieve for the various lives that make it their home, one that can never last, but will remain a chapter in the ever-changing world of 4546b. And so that brings me to the end of this video. This format was a new one that I wanted to try for making shorter videos in between the long ones, which focuses more on the ecological aspects of a game and not looking at every individual species. If you haven't already been able to tell, it's heavily inspired by Curios Archive. I went back and rewatched all his older videos just to get some inspiration. Someone with his own video on Subnautica and a whole lot of other cool ones about speculative biology. I personally recommend his videos about Serena, simply because they're what got me into the field, so to speak, of biology and ecology in general. Without those videos, I probably wouldn't even have a YouTube channel right now. Hopefully you guys enjoyed this, because I know I sure enjoyed making it, and I do plan on covering the other biomes in Subnautica from time to time for sure. And of course, all the while I was working on this video, another longer video has been developing in the background. It's the Deep Rock Galactic video, it's that one, obviously. But that's a conversation for another time. As for now, it's time for the part of the YouTube video where I make the algorithm happy. With that being said, as always, I hope this video has encouraged you to look at the games you play under a more detailed lens, and if you ever find something that you may find interesting, you can leave a comment below letting me know about it. If you'd like the opportunity to know when I'd be uploading said video, or if you just want to support me in general, you can subscribe to my Patreon. In doing so, you'll get a video roadmap for all future videos that I may upload. If you want to support me in a way that does not involve a subscription though, you can also purchase a product listed on my channel. However, you will be missing out on certain perks like early access and a shout out at the end of my videos. Speaking of, thank you to all my current Patreon subscribers, highlighting in particular my high tier subscriber, Meow. And with all that being said, thanks for watching, and goodbye.